Welcome to the MSDN show. Today we've got a special treat for you. Recently, Eric and I went down to TechEd down Orlando, Florida, and did some special filming for their web broadcast to a TechEd audience. We had a lot of fun down there, got to talk to some people.
That's right. We hosted several Q&A sessions, met all the different speakers. I even talked with Bill Gates and Bob Muglia.
It was a lot of fun. Had some parties going on, some hot weather a bit.
Very hot, very humid.
Yeah, and we even had a chance to talk to some of the people out in the audience about what their thoughts are about the show and sign some autographs, I suppose, and stuff like that. But, you know, that sort of stuff goes on.
Yeah, it was lots of fun.
Yeah. Now, before we go on to the rest of the show, I think probably doing a news broadcast is in order.
Time for the news.
Okay.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. Microsoft recently demonstrated to an audience of 14,000 developers at TechEd a new developer tool that is being designed to provide a flowchart logic approach to developing BizTalk applications. This new tool, known as BizTalk Application Designer, is based on the recently acquired Visio technology and provides visual programming access to BizTalk orchestration. It is expected to ship later this summer as part of the BizTalk Server 2000 product. For more information about BizTalk Application Designer and BizTalk Orchestration, you can check out Microsoft's BizTalk website at www.microsoft.com/BizTalk. At TechEd, Microsoft announced the immediate availability of the Digital Dashboard Resource Kit 2.0, which includes a new Internet standards-based approach for building components called Web Parts. Web Parts enables developers to structure the delivery of web-based content and services using a common XML schema, making it easy to manage and distribute digital dashboards throughout an organization with little or no programming. The Digital Dashboard Resource Kit 2.0 is free and currently available for download at www.microsoft.com/solutions/km/digitaldashboard.htm. Recently at Forum 2000, Microsoft unveiled its roadmap for the next generation Internet, signaling a new era of personal empowerment and opportunity for consumers, businesses, and software developers. This initiative, called Microsoft.net, will allow the creation of distributed web services that will integrate and collaborate with a range of complementary services. More information about Microsoft.net can be found at www.microsoft.com/presspass/topics/F2K. On June 26th, Microsoft formally announced C#, a new programming language that has been specifically designed to be simple, modern, object-oriented, and type-safe. C# is derived from C and C++ and aims to combine the high productivity of Visual Basic with the raw power of C++. It will be included as part of Microsoft Visual Studio 7.0, and along with Visual Basic, Visual C++, VBScript, and JScript, will provide access to the next generation Windows Services platform via a common execution engine and a rich system-level class library. Developers can find out more information about C# and its upcoming availability at msdn.microsoft.com/vstudio/nextgen. And that's been the MSDN News Update. I'm Erica Wiechers. Welcome to our special segment of Enter the Programmer. Recently down at TechEd, Robert spoke with Kyle Marsh, and they talked about Win64 and what it means to developers.
Kyle's been working with developers for quite some time now, helping them understand the specific issues involved in moving an application from being a 32-bit application to a 64-bit application. Hopefully he has some good pointers to help you understand what it means to you in your development efforts. Let's go listen to what Kyle has to tell us. Now, Kyle, what do you do at Microsoft?
I'm a developer engineer working on the evangelism team for the desktop operating systems.
And focusing right now on some Win64 issues?
One of the things I'm looking at is Win64. We also look at some other desktop things that are coming up, but Win64 has been a lot of what I've been doing lately.
What does that exactly mean to the programmer? I mean, we just got through having to switch from Win16 to Win32, it seems like, just almost yesterday. But now here we're talking about Win64 already.
Right. Well, the the 32-bit address space has become confining for a lot of applications. So it does mean for the programmer a lot of the similar kind of change moving that we did from 16 to 32, but actually it's a little easier now, because when we did the change from 16 to 32, we put a few steps in place, a few things in order that make this transition a little bit simpler, a little bit easier to do. When we did the 16 to 32-bit translation, we had a lot of APIs that had to be tweaked and fiddled with and worked over. We don't have anywhere near that much this time around, and therefore you can move right into the 64-bit address space, have a lot of memory address space available, as well as a lot of the power of the 64-bit processor at your disposal.
Now, I remember in talking to people about the switch from 16 to 32 and talking about the API and that sort of stuff, there were like many cases where there was a lot of work the programmers have to do just to get their applications running on Win32. Does Win64 still present that sort of barrier, so they're going to have to really take a look at their program, or is it more from the standpoint of taking advantage of Win64 that they need to take and make these changes?
A lot of it's taking advantage. There's a couple caveats there. The big thing is what we call clean code. The first step in getting your application running as a 64-bit Windows process is you need to go through and recompile it with a 64-bit compiler. In order to make that possible today, we actually ship the first pass of the 64-bit compiler in the Windows 2000 SDK today. So anyone who has an SDK has the first pass of the 64-bit compiler. It plug-in replacement for the 32-bit compiler we have today, so you can just put it in a directory and have Visual Studio work with it, or your current build process. What it will do is spit out a number of warnings that do highlight areas that need to be changed. Now, if you've written your software to be very clean, so for example, if you compile under warning level 4 today, there won't be any changes you need to make. In all likelihood, your code will already be clean enough to run a 64-bit. If you're not using a high warning level, or you're using something like warning level 3, you need to use the new compiler just to get an idea of better warning messages that we've tailored for the 64-bit environment. We've already got the pound defines necessary, the data types necessary for 64-bit. If I step back and look at what the 64-bit API set really is, what we call Win64, as opposed to the old Win32 API set, officially or technically it's fairly different. Let's look at send message, for example. Send message now returns a 64-bit value, and 3 of its 4 parameters have become 64-bit. So technically it's a fairly different API. But if I write out the declaration for send message, it still returns an L result, takes an HWin, a message, and a W-param and an L-param. Well, those W-param and L-param data types have been tailored for the right operating system. So on a 32-bit target operating system, they're a 32-bit entity, and on a 64-bit, they're 64-bit entities. So as long as you're passing an L-param type value as the 4th parameter, or what you pass in, so if you have a pointer at the 64-bit pointer, it needs to be cast to something. If you cast it, as you currently do, to pass the warning levels to L-param, everything's fine, you need to make no changes to your code. Unfortunately, a lot of developers, instead of using the proper data type like L-param, tend to cast it to a D word or a long, which was never really right, but it was okay because you got through it. Since the data model is slightly different on 64-bit, one of the big things we did was we were using something called an LLP data model, LLP64 data model. What that means is we're leaving ints and longs as 32-bit values. This is so that portability between 64 and 32-bit is much enhanced. We want everyone to develop their software using a single set of source code. That's how we're developing the operating system. So we have one set of source code, we build a 64-bit version, we build a 32-bit version from the same code. We don't have a lot of pound defines, it's fairly clean. We don't want to make it very difficult to have that process in place. So in order to do that, we've left the ints and longs as 32-bit. Pointers, of course, become full 64-bit entities. Obviously, in order to address the address space, you need a full 64-bit pointer. So we use the entire address space there. So therefore, some of the things like the L-param or handles need to move to 64-bit as well. If you use the data types as they're laid out in the Windows header files, things like L-param, L-result as the return value from send message, you'll be fine on running 64-bit. A lot of applications or a lot of developers have used D words, have used the use of longs and switched them around. So you need to have the compiler, take a pass through the code, and having done that, the chances of your application then just running as a 64-bit application are very high. I've taken a few samples from the SDK, for example, and after cleaning them, where lots of places where the fourth parameter send message is a D word, then they do start running as a 64-bit process, and they're up and running fairly quickly.
Another issue in doing that, even just casting the values to an LParam value, if the developer, in preparing that message code, had a value that was not intended to be a 64-bit value, but they are actually assuming it was a 32-bit value and simply casting to LParam, aren't they still going to have a problem with that?
Well, it depends what kind of value you're thinking of as assuming a 32-bit value. There are cases where you want to continue to leave it as a 32-bit, right? But normally,
there's sometimes where I'd write code and I would do a send message to myself, and I'd have a little proprietary message I'd be using, and I was just simply wanting a value that told me a customer ID or something like that, and I would just kind of pack it into an LParam and pass it to myself in that fashion.
Most of the time, that's going to work, right? Because you've got some variable, right? That thing you're going to pack that eventually you'll pass as an LParam. So you're declaring an int or a long maybe or something, right? That'll be packed into that data will be put into that variable. You'll put that variable as the fourth parameter and cast it currently to a long, or you should have cast it rather to an LParam. If it was a long, a lot of times people wouldn't have done any cast, they would have just got away with it. But if you were compiling at warning level 4, or even in the code you had, you cast that variable to LParam. The fact that that gets moved into a 64-bit entity, the fact that you have 32 bits moving into 64 bits, you're never going to lose anything there. We've plenty of headroom to take what you've already done and put it into one of the bigger data structures. Mm-hmm. More of the problem we have is in code is, one example is list box items, for example. Lots of applications manage things in list boxes. Well, you ask the list box for an index, and because you're going to use it for maybe you're indexing something else, some other data structure on the disk or something based off that index. Send message returns a 64-bit value. So in theory, we're giving you an index that could have 64-bit worth of items in that list box. Now,
none of my list boxes have quite that.
Well, yeah, it's probably not a really good user interface to have more than a few million items in a list box, right? Let alone a few billion items in a list box, right? So in that case, we actually, I'm advising people to not necessarily take that index, which is probably currently an integer, and make it a 64-bit integer, because I'm really probably never going to have more than a couple of billion items in a list box. And by moving everything to 64-bit, like absolutely every data item, I'll just make everything 64-bit and it's simpler, I'm just causing my code to bloat for no really good reason. I'm not going to have more than 2 billion items in a list box without changing that user interface. Therefore, I would in that case cast the return from the send message back down to 32-bit. There's lots of places where people might be doing that. However, say you're getting a handle back. If you try to cast that into a 32-bit item, that's a real problem. You have to go and clean that code. So someone who's taking a return from a send message and casting it to an int instead of a handle, casting it to a handle would have been fine. But if you cast it, a lot of times programmers seem to like to kind of think that they're a little brighter than the compiler sometimes. Oh, I'm not going to use ints and longs. I prefer D-word. It's much more explicit. Okay, fine. Now D-word's not good enough. D-word's not big enough to hold a pointer. So casting the fourth parameter to send message, or taking the return from that send message and casting and saying, oh, this is a D-word, that's problematic code area. If you had said, I cast it to a handle because that's where I'm putting it into, this is an LParam, you're much better shape. The code is clean enough to run.
Yeah. Now, another aspect of taking all of your data values and upping them up to 64-bit would come with streaming your data blobs into a file. Let's say you're trying to maintain a word processor and you basically just took your structures, streamed it into blob into a file. Well, all of a sudden, that file structure is incompatible with your previous versions.
Exactly. So by the fact that we've gone with LLP64, you don't normally try to store pointers or handles of things that have to be 64-bit elements on disk structures. There'd be no point in, say, saving pointers, right? You're just wasting space. But you save a lot of words and ints and longs as structures. So those items stay as 32-bit. So we keep the compatibility between the stuff you're writing on disk, since we've picked that data model kind of explicitly to help compatibility as we move forward, right? So it's one of the main reasons we picked that model, to help the application developer move his code so he can have a 64-bit version and a 32-bit version very quickly and just be running from the same source of code. And then therefore your communications On disk is the same way. We've also made it so that, for example, if you use COM today as an interprocess communication technique, we make that work between 32-bit processes running on the same system and 64-bit. So we make that work. We make our RPC interface work between 32 and 64. Now, if you're doing something other than COM or other than our RPC in order to communicate with another process, and you decide to not make that process 64-bit, but as you go forward, you may not decide to do everything 64-bit right away. You may say, well, I'm going to make this 64-bit, but this application or this other process will stay at 32-bit. You have to be careful about interprocess communication across that 32-bit, 64-bit boundary. We make it just work for COM and RPC, but if you're using something else or something a little more homegrown, you need to be cautious about that.
So are we providing a funking mechanism to get across that barrier?
We are not going to allow, we supply the COM and RPC to do the translation or the move between the two processes. We don't allow the mixing of an address space in a single process. So if you have a 64-bit application, all of its components must be 64-bit. The DLLs, in proc COM, they must be 64-bit. Another process can run on the system as a 32-bit process using what we call the WOW layer, the Windows on Windows 64 layer, which allows 32-bit processes to run on a 64-bit processor on 64-bit Windows. So we'll handle it's not so much a thunking, but we'll handle the translation between those in our published methods.
But you're not wanting application A to get a pointer to a function in application B and then call that function directly?
No, that won't work.
Okay. Could you take and use like send message to send in a message and pass the parameters and wait for message to come back?
Yes, through the windowing system. In the same way that works today on our Windows on Windows, we currently have a WOW layer, Windows on Windows, that runs 16-bit applications in the 32-bit address space of Windows 2000. And the ability to run and say exchange messages or handles to Windows, that was still working. We can still do that on the 64-bit process. So we support that in the same way as we did before. But you can't pass a function pointer and have it make any sense at all on the other.
It's like callbacks just aren't going to.
Right. So we make COM work. We do the marshalling between. Any place where we can marshal, we can handle it for you. Mm-hmm. Otherwise, it's not going to go.
So it sounds like the best attitude then is to try to embed COM as deeply as possible within your applications. So you're exposing COM interfaces, and that way you don't need to worry about it quite as much.
Yeah, you don't need to worry, but we'll do a lot to make it work. Another hint there is if you make most of your stuff out of proc, right, your COM components, so that they could run out, then you have a choice of deciding whether it has to be 64 or 32, and you can stair-step your schedule somewhat. Mm-hmm. If it has to be an improc thing, then you must make it 64-bit right now in order to move forward. Mm-hmm. So you can make decisions about stair-stepping your development a little that way too.
Now, why exactly would a programmer want to be thinking about moving to Win64?
It's headroom. It's all about well. There's two things. There's the headroom of the address space, and we can do a lot of things because we can bring a lot of stuff into memory. You can cache a lot of things. 64 bits data addresses is enormous. Right now, we're going to, in the initial implementation of 64-bit edition, we're going to have just under 8 terabytes as the user addressable memory space. So you can do a lot if you had 8 terabytes of memory to work in as far as caching things. The other thing is just, as a 64-bit process, you can take advantage of a very sophisticated processor. The 64-bit processor is not a Pentium widened to 64 bits. It's a whole new architecture. And a compiler that understands this new architecture can take advantage of a whole raft of new optimizations that this processor enables. Things like predication and speculation. These are very sophisticated techniques in order to move us to a whole new generation of performance on the processor. Right now, the Pentium, for the most part, does things in a fairly sequential manner. The Itanium can do things, many more things at a time.
Itanium?
Sorry, the Intel's 64-bit processor is going to be marketed under the name Itanium, and it will be done out sometime before the end of the year. And its 64-bit Windows at the moment runs on an Itanium processor. And these 64-bit processors are very sophisticated devices. They allow a lot of sophisticated optimizations to really start moving the performance window much higher.
So an Itanium is not just a Pentium with bigger address spaces?
No, not at all. It's a completely new instruction set. It has a compatibility mode to run the old 32-bit processors on the chip, but it's a whole new ballgame. At least, so that means the operating system vendors and the compiler vendors are doing stuff all new, because we're dealing with a much lower level, a whole new process, a whole new instruction set that we're dealing with.
And they're probably getting bored of that old stuff anyway, weren't they?
That's right.
They want a new challenge.
They needed something else to do. At the most application level, who are programming to the Windows APIs, it's not all new. It's a cleaning up process. It's making it run as far as at the first pass of getting your process up and running in 64-bit. Once there, you might make some other decisions. For example, I used to work on a large accounting package, and it was always preferable to do store the dollar values as pennies, so that there was no decimal point. So it's just an integer. Therefore, it stores easier, and it's more accurate, and it's a lot faster. Right? The problem is it only goes to about $400 billion using an unsigned value to do that. Therefore, it's not really big enough for a really big company to deal with. You know, it's just, that's not enough money. Certainly not enough yen, right? So you need bigger values. Well, now I can convert those accounting packages back to using integers because I've got a lot more headspace as far as a lot more yen, drachmas, dollars, whatever, can store in that 64-bit integer. So even, it's not necessarily, oh, it's big databases. Sure, big databases are going to use the memory, cache a lot of stuff. But even something as off the beaten track as, hey, accounting packages could benefit by having 64-bit integers. Right? Therefore, they're doing it as integer math, therefore it's much faster. So if I'm doing a depreciation of a large corporation's, asset set, and I'm doing the tax calculations to do it, we can significantly cut the time down to run those calculations by doing them on a 64-bit processor.
So let's say then you're a programmer and you decide, okay, I'm going to bite the bullet, I'm going to go to Win64. What do they do today?
What do they do today? The first thing you should do that everyone can do and is accessible to everyone is get the compiler out of the platform SDK. Right, it's available on MSDN. You can, everywhere that the platform SDK is available. There's a Win64 directory on there, inside the bin directory, and in there is the first pass of our compiler, of the Microsoft 64-bit compiler.
Again, what's that file called?
One
thing that always bothers me sometimes, you just take and install the new DLL and everything works fine.
Okay.
And it's like, okay, you don't know what the name of the DLL is, you don't know what the tool is supposed to use to install it with, and you don't know how to tell whether or not you installed it right in the first place.
Okay, so install the platform SDK. And in there will be a bin directory inside of that Win64. In there is basically cl.exe and c1.exe, the core components of the Microsoft compiler. Those are things that are called by Visual Studio. Okay? So then the next step is either you can, if you just want to see where you are, you could replace your current copy of C1 with this to see what happens. Or you could point Visual Studio to use this other directory instead of its current directory.
So you map that path in prior to the path of the bin directory.
Right. Or if you're using a makefile or another process, you can just map that path of where these are so that you get the new error messages out. Those we especially have implemented something called WP64, capital W P64 for 64-bit pointers warnings, and we enable a special group of about a dozen or so warnings that are the typical problems we see in applications as they move from 32-bit into 64-bit. So you map in this new compiler, set the warning level to WP64, and then see how clean your code is.
And setting that warning level is something you need to do manually in the command line
Actually,
setting?
there's one other thing. The one other way of using the compiler, inside of the platform SDK, there's a set Win64 batch file, which just sets up all of your environment variables to point to the 64-bit compiler. If you're using, say, a batch makefile, or even if you've exported the makefile from a Visual Studio project, you can run it from a command line. You can call that. Inside of that environment, there's a W64-bit makefile that sets this switch. But if you've got your own environment, you should set the WP64 yourself manually, as opposed to W3 or W4, whatever you're using today.
Because like right now, like in Visual Studio, you bring that up and you've got all check boxes and stuff like that. It's not going to show WP.
It's not going to show WP64. So if you're inside of Visual Studio, I think the easiest way, the one I prefer to use in Visual Studio is to simply do an external makefile. Visual Studio will let you export a makefile, go in and set the WP64 switch in that, and then running that from a command prompt, having called the set Win64 batch file ahead of it, I'm now producing 64-bit code instead of 32-bit code. And from inside of the environment, I continue to build 32-bit code. So if I make a change, I check, make sure it's still running on 32-bit, I haven't broken something inadvertently, I continue to build both at the same time. And I just put a tool inside of the tools menu using the tools customize. I drop a little command that says run the batch file to to run the build.
Okay, so that way you're not accidentally switching to 64-bit mode, and then you go back the next day and you start to compile and you accidentally did 64 and you meant 32.
Right. That way I keep them separate
separated.
and I generate the two projects at once.
Yeah. Now, once they've done that, then, I mean, do they end up with an executable that can run on the Titanium then?
Not at the moment, right? Not from what they get from the platform SDK. If you're past that point, the next step is to actually try to get a hold of an Itanium-based processor in order to run your application.
I think this is not just buying a chip and replacing your...
It's not buying a chip, and it's not going to the store. You're going to need to make a relationship with Intel, who has the Itanium processor today, in order to obtain an Itanium. It's just not available. So, but if you were to present yourself to Intel and to Microsoft saying, "But I'm ready," I'm sure something could be worked out.
There's information on our website that helps people understand this process a little bit better of creating that relationship with Intel, and or do we not have that out there yet?
We don't have that out there yet. Although we do have an alias, DRG Win64 at Microsoft.com. And that alias, if you are at the point where you're saying, "Hey, I'm ready. I've done this clean code, and I've got a product that's going to benefit. I want to get on it." If you were to mail that alias, DRG Win64 at Microsoft.com, we would be able to get things going. We actually have a couple of other ways for some of the smaller ISVs or ISVs who having asked Intel and unable to obtain one, we are operating a way of making Itaniums available over the internet, so that you can have a place to test and run your code. When you have access to an Itanium...
And making it available over the internet doesn't mean like going to Amazon.com and buying it.
No, I'm actually using an Itanium over the wire, using the terminal server as part of Windows 2000, right? The 64-bit version of Windows 2000 is still Windows 2000, therefore terminal server runs on that platform as well. So you can use terminal server to dial up one of our Itaniums over the internet
and remotely
access the machine over the wire. Once you're at that phase, we can give you the rest of the compiler. We can give you debuggers you can use over the internet as well, and now you have an environment to build and test with. If you can get an Itanium on your own, we can still supply that as part of the beta operating system and the pre-release of the pre-beta of the operating system. That includes the tools, the full compiler, debugger, in order to actually develop software. Most of that work still happens on your current Pentium, right? So we compile on the Pentium, with the debugger runs on the Pentium. Over the wire, it remotely debugs the Itanium. So most of it, your tools still live on the Pentium you have today. It's still enlisted in your same source code project. You don't have to have a whole new raft of tools. You just need the new compiler, plug it in place, do the work. When you're ready to run and test, you get a hold of an Itanium that you can access either directly on your site or one of ours over the internet, so that you can test and debug the code.
Now, from a timing standpoint, I mean, if I was a company developing stuff, I'd be more intense about getting a Win64 development environment if I knew that a couple months from now these things would be in common use. What is the time frame we're talking about here for Win64 to be actually out there in people's hands?
Well, we expect Intel will release the Itanium processor toward the end of the year. We'll have a version of 64-bit Windows available for that processor, and we'll have a pretty solid release at least soon thereafter. So toward the end of the year, we expect them to become generally available. And we will have the tools and the operating system you need in place whenever Intel's ready to ship that processor. We expect it toward the end of the year sometime.
So let's look back at your financial program you said you were writing. Let's say you were back in the end of the lifetime and you were working this financial program. How soon would you be maybe expecting some of your customers to be coming at you and saying, when are you going to have Win64 release, because I've now got a machine to use on it? Are we maybe thinking early next year sometime?
It would be, yeah. We're launching a whole new platform here, right? So there are certain chicken and the egg kind of problems that need to be sorted out. Developers need to write software so that someone can buy a machine that is used running the software on. Itanium machines are we don't know what the pricing is. Obviously, that's going to be in Intel's realm. We expect them to be reasonable, but they're not going to be a $500 PC you go down to the local store and buy. These are serious pieces of hardware. They're going to be relatively expensive. You're going to want software that exploits it. So frankly, at the beginning, we see a lot of software developers buying them to get ready and getting 64-bit software. So it'll probably be next year before some of the software starts to show. Now, at least as far as the desktop environment. On the server environment, there's a lot of big server companies who are chomping at the bit to get their stuff going on 64-bit world. So we expect that there's a lot more interest at this point in getting those servers. People like the SQL servers of the world, the big database people, the big internet servers are wanting to exploit this hardware right away. So you might see them a little bit quicker in the server environment. But we also have a lot of interest from the high-end graphics, high-end CAD/CAM kind of applications, where they can obviously benefit from the higher headspace they have today.
So it sounds that for some developers out there, it's right now is when they need to start thinking about getting Win64. For other people, they can maybe wait for a little while.
I think developers should at least be thinking about doing the clean code now. Right, the ability to take it out of the platform SDK and start, even if for no other reason, get a sense of how much work am I going to have to do to get my code clean. And then it can be something that can be worked into your current development schedule as you're doing more work or doing maintenance work. We should start thinking that, hey, everybody needs to do a pass on this to make sure I can clean up the code. So we spread this work out a little bit. I think that's something all developers should really be thinking about doing right now. From there, they can make a decision of when do I actually have to jump in and either buy Itaniums or find a place to borrow one from, and where's my market and how fast will that market move. But the big bulk of the work, which is getting all your code clean, I think that's something people should start thinking about and scheduling into their process right now.
Okay. Well, thanks a lot, Kyle.
Okay.
Enjoyed the information you had to give us. Win64, it sounds like it's getting ready to knock our doors down here, and it's time to get busy on it.
It's very soon.
Okay.
Very soon.
Thanks,
okay,
Kyle.
thanks.
Welcome to our special segment of Diversionary Tactics. You're about to see a video, a little behind-the-scenes look at TechEd 2000 and how 14,000 developers attended sessions and basically had a lot of fun.
Proof positive that even geeks can have fun with the right motivation.
This is true. Welcome to our special segment of Technobabble. Also down at TechEd, Robert spoke with Stan Murawski, and they delved more into the architectural aspects of Win64.
Now, Stan goes by Stosh to his friends, and so down at TechEd, when I talked with Stosh, we talked about the architectural aspects and how that involves in thinking about the development of your application in the early phases, getting it ready for the new Win64 platform that will be coming out pretty soon. So, let's go hear what Stosh has to say about getting your applications ready for Win64. Welcome, Stan.
Hi, Robert.
How's it going?
It's great to be here.
Now, what do you do at Microsoft?
I am also an evangelist, as was Kyle, and I evangelize Windows to the developer community, specifically within the high-end enterprise data center oriented community, and more server oriented, but not exclusively.
Okay, so data center and server, that sounds like the sort of thing that Kyle was saying is exactly who we're going to go after Win64 players.
Oh yes, 64-bit Windows, the Itanium processor is all about what Kyle called headroom. It's up to the next level in scale. It's more transactions, it's more users, it's larger databases, it's larger objects now, thinking more in the workstation. It's more. It's the progression we've made from 4-bit processors to 8, 16,
I remember those.
and now to 64. It's the next step in our evolution of our technology base.
So, in talking about the architecture of what Win64 brings to the table here, what do people really need to understand from that standpoint?
Well, I think I'll tell a story about a trade show where I did a demonstration jointly along with Intel. And on one side of the table were some Intel guys who, of course, are hardware-oriented guys, and they had an Itanium computer with its guts open on the table. And what you could see there, what you could talk about there, is it's a whole new ballgame. It's not x86 anymore. It's not...
So even just looking at the motherboards and stuff like that, you could tell it was not a...
Well, you get that feeling from the nature of the machine, because the whole thing is high-end. The whole thing's about high capacity. The whole thing's about lots of memory. So there are many slots in there to put memory chips, etc. So it's a new ballgame. That's the point. It's a new architecture. It's a new instruction set. But from the Windows perspective, from the user's perspective, from the Win32, Win64 developer's perspective, it's not a new ballgame. It's Windows. It's Windows 2000. It looks like Windows 2000. It runs like Windows 2000. And in fact, if you've got that clean code Kyle was talking about, your code just compiles and works, as do some of the samples in the SDK. So you get the advantage. You get the speed. You get the scalability. You get the big address space. You get the big numbers. And you get it easily. And that's the whole foundation of a lot of our design decisions about the LP64 that Kyle mentioned, to have maximum compatibility so existing code can move forward and get that scale advantage with a minimum investment.
So if the end user is not going to see any difference on his desktop running Windows per se, he's still running Windows. He doesn't know whether it's Win32 or Win64. I suppose if we had updated Win16 to look the same as Windows does, they'd think it's Win16 as well. Doesn't that create a slight barrier for the application developers to create more of a thought of, I've now got a better application running on this system?
Better is going to come two ways. And the main way better is going to come is speed. Itanium is about scale. So if we're talking about end user, we're talking about workstation, we're talking about something you see right there firsthand, it's speed. Believe it or not, from a consumer perspective, there's a lot of applications at the high end. For example, solid modeling simulations, or maybe engineers at an automobile manufacturer that are doing vibration analysis, trying to decide about suspension bushing thickness. Those guys are out of capacity. The 2 megabyte address space isn't big enough. Or the processor time is such that the simulations take hours and hours to run. Well, if you can take a 4-hour simulation and change it into a 2-hour or 1-hour simulation, so you can afford to do twice as many or 3 times as many before you make your design decision, that's a huge advantage.
So it's not necessarily the same people are now one day running Win32, the next day running Win64, but it's almost like people that weren't previously able to run Windows for this problem. Maybe they ran Windows on their desktop to do their word processing and spreadsheets, but they went to the floor of their equipment manufacturing company. They had to switch to some other system to get that stuff. They can now be running Windows in both those scenarios. One's a 32-bit version and one's a 64-bit.
Well, certainly that's true. Although I have to bring it back to time. There are software systems for things like these simulations we're talking about that cost hundreds of thousands of dollars in licensing fees. The engineers actually schedule slots of time to use the simulator on the computer it's on, whether it's currently Windows or not.
Again, like I used to do in college, and schedule time and got TSS
well,
systems.
The schedule time is the same, and the limited availability is the same, and sometimes you need to come in at night is the same. If those slots become 2-hour slots instead of 4-hour slots, twice as many people can get in, or you can get in during the day, or you can get twice as many shots, so you can do a better job.
Mm-hmm. And so maybe then you're not even seeing necessarily the interface, you're just submitting a job to a system across the internet, perhaps? And so
Well,
you're never
it-
physically, visually touching or seeing the computer, but is running Windows, it's running Windows code because the developers writing that code are so familiar with the platform that they're able to make that great application code running on Win64.
Yes, and now you're talking more like a server scenario.
Right.
And the server could be deployed in this large batch job kind of mode where we're running a large simulation that takes many hours. Or we can use these machines in the .com world. We can put up larger databases that support more concurrent users and a higher transaction rate for the kind of volume demand that's out there in web-based internet applications. For example, the Windows DNA scenario.
Now, I know one class of application that I heard about that was seriously looking at Win64 as something that was important to them that kind of caught me by surprise was the games market. What are your thoughts on that?
Well, my thoughts on that are that it's ironic that the gamers are the guys that have the highest hardware demand and the guys that are buying the most expensive machines out there for the desktop. Server aside, the .com guys are buying big, fast machines and maxing them out. But in the home desktop scenario, it's the gamers that have the high demand, both the graphics and video demand and now the memory for the size of really simulations they're running with these multiplayer worldwide internet-based games. So yeah, I think they'll get there. I don't think it's going to happen with the first set of boxes that ship at the end of this year, but they will get there.
But I mean, it's kind of interesting. You have almost on two opposite ends of the spectrums. You have your high-end business usage, and then you also have your in-the-home entertainment stuff. In the middle of that is like your word processing, your databases, your modem communications, your browsers, and so forth like that. Are they being left out of this Win64 jump from a need standpoint, or are there things that they actually can use on Win64 as well, and you see Win64 coming into the home in that fashion?
Well, I think that's why we have the Win32 simulation or the Win32 support with WoW64 on 64-bit Windows. Now, there are apps that run at, let's call it keyboard speed. They don't need the advantage or really get any advantage from going faster. They're fast enough, and they're, for some people, support apps, so they've got to run well on 64-bit Windows. This engineer at the auto company is also doing email. So he's going to flip over to his email client, and he's also writing reports. So he's going to flip to his word processor. So they've got to be there. They've got to run correctly. But they don't need more scale. So 32-bit versions of those apps need to get QA'd and tested and validated. And they're good.
Here's, of course, until you add all those super fancy special effects to your word processing so the letters dance around on the screen and start acting like a game or something like that I'm sure some people out there probably want in their word processing. I don't.
Well, I think those guys can get by with a 1 gigahertz Pentium.
Okay. What do you view as the most important things for an application architect designer out there that's thinking about the next version of their application or the current version of their application? What do they need to focus on to get their team involved in Win64 development?
Well, what's the advantage of 64-bit Windows? What's the advantage of 64-bit computing? At the lowest level, it comes down to large integers. Instead of a 4 billion as a maximum amount I can count in a single integer, which at the hardware level means in a single register, I can now count to 4 billion. So it's a much, much bigger number. So if I have an app that's counting many, many, many things, that happens in a single register now, so it can happen very rapidly compared to the kind of algorithms you have to devise if you have to count in 2 registers, one of which counts how many times the other one filled up. So statistical kinds of processes, particularly in a scientific scenario where, atom disintegrations, et cetera. And the other one is pointers, large pointers. So the integers go to 64 bits, the pointers go to 64. What that large pointer means is I've now got a memory space that instead of being 2 gigabytes to the application program is 8,184 gigabytes. So let's imagine video editing, which is an application that even is coming in to the home. If I'm editing a large movie, Star Wars, I'm editing Star Wars, and I've only got a 2 gigabyte address space like you have on a Pentium computer, I have to map that movie into memory in small chunks of just a few minutes. And my program and its design has to think about which piece of the movie's in memory, which piece of the movie's in disk, and God forbid the user's going to want to edit across the boundary between two of these pieces. Then it
Almost
gets
sounds
very
like the old
complex.
memory mapping we had back on the 8086 days with lamb and lamb and all that sort of stuff.
Right, and it's a hassle of doing things piecemeal when the natural way to do it is to look at the whole movie as a single stream of data. Well, with 64-bit Windows, I have this 8,184 gigabytes to work with. I can map the whole video. I can use the file mapping APIs, map the whole video into memory, and have much more simple programming model now for how I deal with this. It's just one nice linear stream of bytes, stream of data, stream of movie. Editing becomes simpler, the code becomes simpler, so in addition to more speed, there's fewer bugs.
And the application developer can take and focus more on developing an application that edits movie rather than trying to develop an application that edits movie and has to manage memory in this weird way of making it appear like it's one big stream when it's really multiple streams.
Right. More of what's in that application now is video editing,
Right.
and less of it is manipulation of lower level entities because of limitations in the state of the art of computing, really.
So from an architecture standpoint, it basically simplifies things.
Yes.
So the architect can now think about
Yes.
their problems that they're really trying to solve and how the problems are being imposed upon them by the architecture of the platform.
That's a very good way of putting it, Robert. That I can now have a new simplicity approach to the design of my programs because I've got more capacity in the operating system and the hardware below it.
What have been some of the challenges for the Windows development team themselves in developing Win64 on top of taking the Win32 code base and moving it to Win64? Because to a certain extent, isn't that the same sort of problems that other application developers are going to run into?
Yeah, I mean, truth is that some of our own programmers inside Microsoft made some of the same short-sighted choices that are in code all over the world and seen even in some of our samples in the SDK. And Kyle's example, I think, was really excellent about using long as a typecast for a parameter in a send message. I remember years ago telling programmers, well, let's go back a step further. In 16-bit world, everybody used Word, and that meant 16 bits. And when we ported it all to 32, we said, well, it's all long now, it's all 32 now, so we cast it to long. And I remember being on programmers saying, don't say long there, say LParam. And the programmers would say, well, what's the difference? They're both 32 bits. Well, that was short-sighted thinking. They were both 32 bits in Win32, and they're not today. So if somebody did program with that thinking forward mode, they put LParam in that cast, it just compiles clean. Some of the samples in the SDK just compile and run. And so that's most of the issue. It's mostly a mechanical issue of dealing with short-sighted choices made in the old code.
I remember in the days of getting people moved on to Windows NT early on, first off, we'd help them port their application from Win16 to Win32, and during that process, they would discover a lot of things that they were able to fix in their code to make their code, even on the Win16 model, they were still maintaining better. And then also when we had the multiple platforms, we had the DEC Alpha and the MIPS machines, and people moved across into those platforms. Every time they ported their application to one of those other platforms, they learned more and more about little inconsistencies that they actually had in their code, fixed those up, and made all the other versions more stable. So in taking a Win32 application, porting it to Win64, seeing where they made these improper assumptions, do you think that might possibly also solidify the Win32 code base for them as well?
I believe that if you take your code and you use the new polymorphic data types that are in the new headers that are in the SDK that Kyle referred to.
Polymorphic data types. I don't think we've mentioned those yet.
A data type which, when you compile it with a 32-bit compiler, compiles to a 32-bit entity, and when you compile it with a 64-bit compiler, compiles to a 64-bit entity.
So the code stays the same on both platforms.
Right. So I think the mantra, the soundbite for Kyle's discussion would be no source fork. One single set of sources, you compile it with a 32-bit compiler, boom, you've got Win32 code that runs on Windows 2000 on Pentium. You compile it with the other compiler, you've got Win64 code that runs now on Windows 64-bit Windows 2000 on Itanium. And if you get your code to that point of cleanliness, that doesn't sound like good English, get clean code that compiles both ways, it's going to be better code because you're going to have thought through more fully the issues about going both ways and what your data is really doing, what your code's really doing.
And so an LParam is one of these polymorphic types.
Right.
So an LPAM does not by itself define a size. It defines more of a concept of what you're trying to get to, and it does the right thing on the different platforms, whereas Word and DWord conceptually define their size by the size of the computer itself.
Exactly. And there are these polymorphic types that have the names of the entities they're working with, like LParam is dealing with a long parameter, that are derived, in fact, from pointers. And pointers are the core or foundational element that goes 32 or 64.
Now, what if you wanted to take and work with a pointer? How would you take and define a pointer so that you really understood what was going? Did you just say pointer and it just becomes 64?
In fact, a set of the new types that are in the new header file end with underscore pointer. It said DWord underscore pointer says I have a pointer now that points to a DWord. But the pointer, it's the size of a pointer for whichever platform I compiled for.
Mm-hmm. So you can keep it straight. And what if you needed to take and deal with the case where you want to do like pointer arithmetic? And
Pointer arithmetic?
okay.
We're talking about clean code here.
I always have fun with pointer arithmetic.
Oh, the worst sin, I'll go that far, in some of the code that we've looked at, is where programmers used the top bit in a 32-bit address. They knew that out of the 32 bits, since the bottom 2 gigabytes belongs to the user and the top 2 gigabytes to the operating system, that top bit's never used, so I can use it for a flag.
And that's not a good thing?
Well, when you go to 64 bits, that bit 31, that 32nd bit, well, that's just one more bit in the stream of bits. So you're going to get bitten by that bug.
Okay, so pointer arithmetic is out then, huh?
Well, it's actually not out anymore in 64-bit than it was in 32. It's just always been let's call it a dangerous thing to do.
Okay. And it's
Proceed at your own risk.
It's fun though. What other things do you think architects should be, concerned about? Okay, one thing is concerned about no more pointer arithmetic. Just get rid of all that stuff and fire all the programmers that are doing it, and making sure your application is polymorphic enabled so that it can compile cleanly. Now, are you also wanting to get rid of if-defs to separate 64-bit code from 32-bit code?
You probably don't need any in your code. If you do it right, one of the fundamentals to get to the point you're making is to cast to data types that are representative of the entity you're working with. Don't say long, don't say word, don't say something specifically 64. Say LParam because it's a long parameter. Mm-hmm. And that's what's going to compile right, and that'll work, and someday in the future we'll probably be talking 128 bits, right? Or maybe it'll jump to 256. It'll still work because it is a long parameter, and that does the right thing for the system you're compiling for. I lost my point.
We're talking about if-defs.
Oh, yeah. The new header file, the name of that header file is base.tsd.h. That's in the platform SDK that defines all the new types, and it's automatically included by the new Windows.h that's in this generation of the SDK. All the if-defs are there to deal with the platform dependency of whether you're compiling 32 or compiling 64.
So that's where all the types are being defined, and that'll depend on what's going on.
Exactly. So the occurrence of needing to put an if-def in your own code is going to be 0 to low.
So you should probably look for any if-def Win64s in your code, or where you need to do that, and see that as a potential problem that you might want to try addressing in a different fashion.
You're probably thinking about the 1632 transition and the number of times you had to say if-def Win32.
I had to do that a lot.
Else Win16. And that's because there was vastly more difference between Win16 and Win32 than there is to Win64. In fact, I almost don't like using the term Win64 because it implies that there's a new API with substantial change, and there isn't. It's the same API set. There are not changes of the order of arguments. There are not changes like in Win16 to 32 where the data stored in LParam and WParam had to be swapped because the sizes of things changed and didn't fit anymore. It's much simpler change than that.
So you call it 32 left shift 1 then, right?
Yeah.
Okay.
I mean, it really comes down to the fact that pointers and items derived from pointers, such as handles, are 64 bits wide. And that's it. It's not a new API.
Not a new API. So that's your mantra. It's not a new API.
Right.
Kyle's mantra is never code fork. Never use a code fork.
Right. No source fork.
No source fork.
And if you get to this Win64 set of code with no if-defs in it, it'll build both ways.
Okay. Well, thanks, Dan. I'm sure our audience appreciates, understanding, a little bit more about the architecture of Win64. Kyle told us a little bit about the availability of Win64. It's coming soon in certain time frames, depending upon what sort of application you're developing. More information, I'm assuming, will be exposed off of MSDN.Microsoft.com as well as standard www.microsoft.com.
I'd like to mention that there are good things now on the Microsoft website. At www.microsoft.com/Windows 2000, if from there you search on 64-bit, you will get about 10 hits with 64-bit information that's directed at management, IT managers, etc. And on MSDN, if you search on Win64, you will get many hits that give you the same information that's in the SDK. And one of the files that's there and one of the files that's in the SDK I want to mention that Kyle didn't, the starting point file, readme64.txt.
That's in the SDK.
Yes, and also MSDN Online, which gives you the description of those details you and Kyle went through about how to set up your compile, how to set up your environment, and take advantage of what's there today.
Mm-hmm. Well, thanks, Dan. And as you work with more developers out there in the world and get more white papers and technology backgrounders and development samples and stuff like that on the web, I'm sure our audience will enjoy taking a look at them through MSDN@Microsoft.com, and we'll make all the information available, and your name will be on most of them, right? Okay.
That's the plan.
Okay. Thanks, Dan.
See ya.
Okay. To continue the Tech Ed theme for the Summit at Microsoft.com, we're going to talk with Dave Washa. Now, he did a demo for Bill Gates' keynote at TechEd, which is a pretty stressful thing to do. After the demo, we then talked to them a little bit about the technology he was demoing. So take a look at some of this footage about that we did at TechEd, and then afterwards we'll come back and talk with Dave and find out a little bit more about him. So check this out.
Welcome, David. Hi. It all begins in the visual design environment. This is where the business analyst and IT professional meets the developer. On the left-hand side of the screen is where the business analyst or the IT professional would use these elements to describe our business process. And then on the right-hand side of the screen is where the software developer would connect that business process up to the components and applications and web services that do the work. I want to build a quick two-step process here. And what I want to do is get an order off of a queue from a customer. And I want to use a telephony component I built using Visual Basic to give them an automated phone call and let them know that we received their order. So what I've done is I've dragged some action elements out here, and we will connect them together. And let's call our first action get PO. Oh, let's spell it correctly. Didn't spell it correctly. Let's call our second action call the customer. And there we have it. We've designed our business process. This is the first step in using orchestration to build business processes. The second step is connecting this process up to the software components that do the work. Now, I know that my orders come in off of a message queue. So I'm going to drag the message queue adapter onto the screen. And I'm going to indicate which queue we want to get our messages off of. And then we simply need to connect the queue to our get PO action. And we've completed the first step. Now, the second step, after I get the purchase order, I actually want to extract the customer's phone number out of that and use it and pass it to this VB telephony component that's going to call the customer and confirm that we've received their order. So what I'm going to do is I'm going to drag the component adapter onto the screen. And I need to indicate which component it is that I actually want to use. And then I need to indicate which method on that component that I want to call when we get to this step in the process. Once we've done that, let's bring that over here so everyone can see it. Once we've done that, we simply need to connect our second action to the component, and we've completed the process. Now, what have we done here? We've designed our business process, and we've used the adapters for the MSMQ and for COM components to connect the business process up to the things that are doing the work. So if we go ahead and we'll validate this to make sure we've dotted our I's and crossed our T's, make sure we've done everything correctly. Now let's go ahead and save this. And what we're actually doing is compiling this business process into XML. Let's take a look at what that XML looks like. So what we've done, and as you can see, there's a lot of code here, and luckily we don't need to write any of this ourselves. The business process designer does this for us. What we've done is we've designed a process, we've connected it to the components that do the work, and we've compiled it into an application. This XML code is the code that will be executed at runtime by the BizTalk orchestration engine. So now that we've compiled it, I want to go ahead and run this process. I've written a simple VB script that's going to run it. We'll go ahead and run it. And if it all works correctly, I should be getting a phone call on my cell phone here in a few seconds, letting me know that they have, in fact, received the order that we've taken off of the queue and handed to the Visual Basic component. So we go ahead and answer that.
This is a message from worldwide suppliers to inform you that order 1040 has been received and will be shipped within 3 working days.
Great. So we know that our component works.
What I saw on stage that was actually kind of exciting. I mean, I was seeing a flowchart, like just my college days, and I was taking all these flowchart classes and saying, when the heck am I ever going to use this stuff again? And actually, I never really have.
I mean, it is exciting, and sometimes when I show people that demo, they're not really that impressed because they don't understand what we're doing. I mean, we're literally changing the back-end business process of a complex system by drawing a picture. And so once you get that point across, people start to say, wow, oh my gosh, I can't believe that we can actually do this. We spent a lot of time building this technology, and it is the coolest stuff. I mean, I'm as excited about this technology as I've been about any technology we've worked on at Microsoft.
I mean, now, for the most part, you draw a flowchart and then just connect up code that defines the processes.
I mean, it is a new concept, and it's a new way of building applications that people are going to have to get educated on. This notion of separating the business process from the components, the applications, the web services that do the work is a new concept. I mean, today, like I said in the demo, the business process is mixed in with all the code that you use to write the method calls and the database functions, and that, I mean, it makes it difficult to build a process. It makes it really difficult to change a process. If you want to upgrade an application or add a new component, you have to go jumping into all of your code in order to make that change. So it only makes sense to separate the two out, and that's what we've done essentially, is enable people and developers to do that with the BizTalk orchestration technology.
Now, do you see this as possibly changing the way that developers and corporations think about the architecture of their application overall?
Good point, yeah. It really is going to bring the business analyst or the IT professional, the person that has historically drawn the diagrams, together directly in a single visual design environment with the people that are writing the components that actually implement what the business process diagram wants them to implement. So I think it's going to help those people to work more closely. And as far as changing the architecture, we're going to be able to think about process without having to think about the limitations of software, and vice versa.
Now, I noticed the tool you're using was based on the Visio code base.
Mm-hmm.
How well does it tie into other development platforms?
Well, what we were actually emitting is an XML syntax. And that XML syntax is going to be open, and we're going to allow other tools vendors to go in and emit that XML syntax for consumption by the BizTalk orchestration engine.
So just saying, any tool that developers used to using right now for their website development or back-end code, methods, properties, events for COM components, stuff like that, they can now connect up this via the BizTalk XML language and stuff like that. Now, could you imagine a company that's not doing web-like stuff? Let's say you were a corporation that had some internal processing of forms and so forth like that. Does this also work in that fashion, or does it need to be an e-commerce sort of solution?
That's a great question, and it's one thing that I didn't really hit on in the demo. BizTalk orchestration is for orchestrating any business process, and that means behind the firewall as well as going over the firewall. So a good example would be customer relationship management. There, no CRM vendor has the best of breed piece of software for every piece of your CRM solution. So
CRM stands for?
Oh, I'm sorry, customer relationship management,
Okay,
right?
okay.
And so what our customers are doing is they're going out and buying pieces from each of these customer relationship management vendors, and they need to string them all together. And this would be an ideal technology to do that, and all of that happens behind the firewall.
So that's what went on at TechEd. Now, we've got Dave here with us, so let's spend some time chatting with him to find out more about not only what he demoed, but also a bit more about Dave himself. Now, so Dave, I know one of the questions after watching the demo and hearing about the technology is, like, where can they find out more information about it?
Well, you can find all the information on the BizTalk product on www.microsoft.com/BizTalk.
Okay.
It's the place to go for all of the information.
Now, what was it like doing a demo in Bill Gates' keynote?
Well, I don't know what was more nerve-wracking, doing a demo in front of 14,000 people or doing a demo in front of Bill Gates. But we were really well rehearsed. We spent a good deal of time, several days before, making sure that everything went perfectly. And obviously, we have all the AV guys backstage, making sure everything is going smoothly. I got to meet Bill the night before and go over the demo with him, and that was interesting. And it went really well. I think we were well prepared, and it went well. So it was pretty exciting, but nerve-wracking at the same time.
So would you say that's your most stressful moment at your career at Microsoft, or have there been others?
That was definitely one of the most stressful. I mean, even when everything is really well prepared and you've gone through it 100 times and you do it pacing backstage, you're still not sure. There's always that tense moment when is the demo going to work or not, because everyone's seen when the demos crash, and it's how right there on stage with Bill Gates, and you don't want to be remembered as the person whose demo crashed at TechEd.
Right. Wouldn't be good.
So yeah, I mean, as far as a single moment of stress, yes, that was probably the most stressful moment, but it was also the most exciting. But afterwards, it was exhilarating to be done and
So what then is your best memory of TechEd?
That was, I mean, meeting Bill the night before and discussing the demo with him. I'd never met him before. It was the first time I met him. Discussing the demo with him, he was really excited about it. He's excited about the technology. And so that was very, reassuring and exciting that the chairman is excited about the technology that you're working on. And going through the rehearsal and working on how we were going to portray the product. And then actually getting up the next day and walking out on the stage and looking out at the sea of 14,000 people was also amazing. So those are some great memories.
So besides doing demos for Bill Gates, what else do you do day-to-day at Microsoft?
Well, when I'm not speaking in front of 14,000 people, I'm actually a product manager for BizTalk Server. And what that means is I'm the public-facing person for the product. I do things like I work with press, I work with analysts, I work with customers to find out what they need in a product, and then I work with the development team to make sure that the customer demands and the customer requirements are then added back into the next version of the product. So, and I spend a lot of my time trying to come up with the best way to explain how the product, what problems it solves, and how it can solve the various problems and challenges that people are facing today. So.
Now that the TechEd's been over for a couple of weeks, have you been getting a lot of input back about the demo you did and some of the new, the BizTalk orchestration server and the application design tool?
Well, yeah, it was a huge announcement for the product, and it really put the product in an entirely different category than it had been before. We got a really great reaction from the press and from customers. I've been inundated with email and requests to do the demo again and other talks. In fact, I'm going to be doing it in Europe next week, again at the TechEd keynote in Amsterdam.
It's great. You got a lot of practice after 14,000 people in Orlando.
After anything less than 14,000, I can barely get out of bed to go do.
Not worth my time.
Yeah, it's not.
So, besides work, what do you do for fun?
Well, I work for fun. That's all I have time to do now. This is a very busy time in our product cycle, so I haven't been able to get out much. But I do have a dog, who is my buddy, and he reminds me to go out and have fun. So I walk him every day. There's a nice dog park near Microsoft's campus that I take him to. And last weekend I went to a concert at a venue near Seattle to go see Bob Dylan. So That was pretty cool.
Fun.
Yeah.
So how long have you been at Microsoft, and what were your first jobs there?
I've been at Microsoft about 3 years, and one of the first things I was doing was this little-known technology called XML. And I remember, and in fact, it was interesting to go and meet with the press and analysts again, talking about BizTalk, because they were the same people I was trying to explain. This is what XML is, back before it became a standard. So I've really seen it come full circle from XML as this thing, this kind of mysterious thing that no one really knew about, to now it's this foundational layer that all of these applications and server products and companies are betting their viability on.
Because BizTalk is based on XML.
Exactly. BizTalk is meant to solve the problems. I mean, XML is a good first step, but now everyone has a different way of using XML to define, like, for example, a purchase order. So BizTalk helps to solve that problem by turning what you think of as a purchase order maybe into what I would use as a purchase order. So it does the transformation.
Well, thanks, Dave. We appreciate the time you spent with us here, chatting about your demo, your personal life, or your dog anyway.
Right.
And we look forward to talking again in the future.
Great. Thanks.
Thanks.
Well, that's our show for today. We hope you enjoyed our first on-location episode of the MSDN show, where we talked about Win64 at TechEd. We had a lot of fun down there, didn't we, Robert?
We did. There's a lot of exciting things going on, and there have been a lot of exciting announcements coming out of Microsoft with new platform technologies and development capabilities and stuff like that, like C#, like you talked about in the news. And so pay attention to future episodes of the MSDN show. We'll be bringing you information about some of these new advancements coming out of Microsoft. Until then, we'll see you on the web.